Let's learn the derivatives of the sine and cosine functions. Derivatives of sine and cosine. So the first thing I'm going to do is I will just tell you what the derivatives are, because that's really the key here when you're learning your derivative rules. However, we will also look at the limit definition of derivative to see why the derivatives are what they are, and then you'll have a little background as to why they are, and it will also be a good reminder of some trigonometric identities that you should know already. So first of all, the derivative of the sine function is the cosine function, okay? So if you differentiate the sine function, you get the cosine function. And vice versa, if you differentiate the cosine function, you almost get the sine function, but you get the negative sine function, okay? And there's kind of a common theme when you differentiate trig functions. If you differentiate any of the co-functions, cosine, cosecant, cotangent, you're going to get a negative answer. So that's something I'll just point out right now. Now, this video is not focused on any other functions but sine and cosine, and I'll have other videos dealing with the other trig functions. But let's take a look at why this is true. So the first thing we'll do is we'll kind of look at the limit definition of derivative as it applies to the sine function. So the derivative of sine of x is the limit as h approaches 0 of f of x plus h, so in this case sine of x plus h, minus f of x, which is sine of x, all over h, okay? And then this is the part I mentioned where it's good to remember your trig identity. So here we'll apply the addition formula for the sine function on the top. So we've got the limit sine of x plus h is the same thing as sine x cos h plus sine h cos x. Okay, so that's the sine of x plus h, and then we just need to do minus sine of x here. That's all over h. All right, now some interesting algebra happens. If we look at the terms on the top, we can see that the first and last term have a common factor of sine of x. So what we're going to do is factor out the sine of x, leaving a cosine of h for the first term and leaving a minus 1 for the last term. So all I did was factored out a sine of x from the first and last, and then what remains on top is plus the sine of h times the cosine of x. And again, this is all over h. Okay, so we just used the addition formula, and then we factored two terms that had a common factor. Now what we're going to do is, since we've got this plus sine h cosine x, we're going to split the fraction apart into two separate limits. So now we have the limit of sine x times the quantity cosine h minus 1 over h, and again h is going to 0, plus the limit of sine h cosine x over h, okay? And at this point, when we look at each limit, which again as h is going to 0, we can see that in the first limit, we've got this factor of sine of x. And since sine of x is not dependent on the value of h, we can factor that out to the front of this limit. So we've got the sine of x times the limit as h goes to 0 of the fraction cos h minus 1 over h, okay? Plus, we'll do the same thing here. Cosine x is a factor that doesn't depend on h, so we'll pull that out to the front of the limit. And what remains is sine h over h, okay? And so what's interesting here is if you were to keep it very simple, you could use things like the squeeze theorem and all that to find these limits. But instead, I'll just tell you, if you were to use your calculator and look at the limit as h goes to 0 in this function, right, you'll see that this limit, this particular limit, goes to 0, okay? And you would see that this limit, as h goes to 0, of this ratio goes to 1. And so what ends up happening is you get sine of x times 0, so that's 0, plus cosine of x times 1, which simplifies to just be cosine of x. So the derivative of the sine function is cosine of x, okay? And we can do the same sort of idea for the cosine function. So if we were to apply that, we would have the limit as h goes to 0 of cosine of x plus h minus cosine of x all over h. And then we'd use the addition formula for the cosine function to expand this. The addition formula is cosine x cosine h minus sine x sine h. And then I'll copy my minus cosine x on the top. Okay? And similarly, my first and last terms have a cosine x in common, so I'll factor that out now. So I've got cosine x. Here I'm left with a cosine of h. Here I'm left with a minus 1. And then I'll copy down my minus sine x sine h. And that's all over h, okay? And then furthermore, I'm going to speed this up now because we've done it once. I'll split the fraction apart, and I'm going to go ahead and factor the cosine of x out to the front of the limit and the sine of x out to the front of the limit, all at once. So my first fraction, right here, cosine x times this binomial over h, I'm going to pull my cosine of x out to the front, times the limit as h goes to 0 of what remains is cosine h minus 1 over h. And then, here's the key, I have minus, now I've got sine x sine h over h, so I'll pull the sine x out, multiply it by the limit of what remains in terms of h, which is sine h over h. And similarly, we have the same two limits we had before. This limit involving the cosine, again, you could check it out for yourself, goes to 0, and this limit involving sine goes to 1. And so we have the same process. Cosine of x times 0 is 0, minus sine of x times 1 is just negative sine of x. Okay? So you can see that the derivative of the cosine function is the negative sine of x function. Now again, I wanted to go through this process so you could see why these derivatives are what they are, but typically you just need to know those derivatives, okay? So make sure to know those. If you got something from this derivation of the derivatives, fantastic. At least hopefully it helped you recall your addition and subtraction formulas for sine and cosine.